Hi and Assalamualaikum. We are from Group 6 and are going to present our group project. These are our group members, which consists of 4 students, which is me myself, Kamarul Adam. Next is Azrul Azam and Wan Mushrif, and last but not least, Harith. First thing first, we are going to go through to the introduction. The aerospace industry demands materials that can withstand extreme conditions like high altitudes, temperature change, and radiation. Electrical, optical, and magnetic properties are essential in ensuring the performance, safety, and functionality of aircraft and spacecraft. Electrical properties support power flow and lightning protection, while optical properties enhance the visibility and thermal control. And last but not least, magnetic properties aid in navigation and steer. These projects explore the scientific principles, real-world applications, and the impact of these properties on aerospace component design.
Hi, my name is Wan Mushrif bin Muhammad Nasir. I will explain about electrical part, and I choose avionic wiring and signal transmission. Okay, for the basic principle of it is it consists of 4, which is electrical conductivity, signal integrity, shielding and grounding, and twisted pair and impedance matching. Okay, so for material use, for electricity carrier, it use copper or silver, and wire cover, Teflon, Kapton, XL, FTE, and for wire wrap, copper braid and aluminium foil, and lastly for connectors, it use nickel or gold plates brass. For its functionality, it consists of 3: power distribution, which is must for consistent power delivery. Second, data transmission, essential for communication, radar, and navigation system. And third, system redundancy, it is redundant wiring path to improve security. So for environmental challenge, first of all, heat and cold can damage wires. Second, vibration during flight can break wires. And third, electromagnetic interference (EMI) can disturb signals. And fourth, moisture and pressure change can cause damage to the wire.
So for my part, I will tell about the optical, which is I choose fiber optic gyroscope as a properties. So the first is I will tell about the basic principle, which is Segnet effect. FOG work by sending 2 light beams in opposite direction through a long coil optical fiber. When the system rotates, the path length change due to rotation, causing a phase shift between the 2 beams. This phase difference is proportional to the angular velocity of the system. So for the functionality, it used to accurately measure the rotational movement of an aircraft, spacecraft, or drone, enabling precise navigation, altitude control, and stabilization without relying on external signals. How it works? It functions by sending light through a coiled optical fiber in opposite directions, and any rotation of the system causes a phase shift between the 2 beams, which is measured to determine the rate of angular velocity. So next, I will tell about the material used in FOG. So the first one in fiber optic, which is they use fused silica because extremely low optical loss, high flexibility and thermal stability, and last, resistant to radiation in space applications. Next, FOG casing, which is they use titanium alloy because of the high strength to the weight ratio, excellent corrosion resistance, and also withstand high vibration and shock environments. And the last is for laser diode as a light source. They use indium gallium arsenide phosphide, which is emits stable coherent light in the near infrared range, typically 1.3 to 1.55 micrometer, and also compact, energy efficient, and long lasting. And last is I will tell about the environmental challenge. The first one is extreme temperature. Extreme temperature at high altitude or in space can cause thermal expansion of optical fibers, leading to measurement drift. Next is intense vibrations. Intense vibrations and mechanical shocks during flight or launch can misalign optical components or damage the fiber core. The third one is atmospheric pressure, which is rapid change in atmospheric pressure may affect the housing if not properly sealed. And the last one is electromagnetic interference. Exposure to electromagnetic interference from onboard electronics or radar system can disrupt signal processing.
Good day everyone. Magnetic shielding in avionics is used to protect systems from electromagnetic interference or EMI. It works by using high permeability materials like Mu metal to redirect magnetic fields. Next, it's commonly used to shield sensors, gyroscope, and navigation units. Materials like Mu metal and copper are chosen for their shielding performance. The main challenge is ensuring the shielding is lightweight yet can withstand heat and pressure in aerospace environments. I think that's all. Thank you.
In conclusion, electrical, optical, and magnetic properties are essential to modern aerospace engineering. They enhance the performance and safety of systems by ensuring proper power flow, thermal control, and lightning protection. These properties also support critical functions such as navigation, sensor accuracy, and communication reliability. With the rise of advanced technologies, understanding these materials' behaviors allows engineers to innovate and design aircraft and spacecraft that are lighter, more efficient, and capable of operating under extreme conditions. That's all from our group. Thank you.